Hi, Kinesiology 3010. Welcome to our video lecture on how to calculate a dependent t-test, or also known as a paired t-test or repeated measures t-test. In this case, it is a repeated measures because we're looking at a pre and post intervention. But remember, all of those t-tests, all dependent, paired, and repeated measure, are all the same statistical tests. There's just different names based on the study design. How we are collecting the data determines the name of the statistic. Okay, so we're going to first start off by determining why we're going to use a dependent t-test. So here we see a pre and post intervention for VO2 max, or this is cardiorespiratory fitness, maximal oxygen consumption, pre-intervention and post-intervention. An intervention, remember, is some kind of something that we put onto our participants that should, or we theorize that will, or hypothesize that will create a change within the group after that test. And we're seeing if there is a statistical difference between pre and post intervention. So is there a difference in these individuals now that we've performed this intervention on them? Okay. So our first step is to look up or to calculate our mean difference, okay? And we will also need a column for the mean or the difference squared. So we're first finding out the difference between the groups, okay? And then we will find the mean difference. How we calculate the difference between group is if we are looking, or we look at pre versus post. So if I think that it will be larger, or my variables will be larger in the post compared to the pre, I will subtract pre, or we'll subtract the post from the pre. So equals post minus pre. Okay, if I'm looking for a difference where I think that the post will be lesser than, I will subtract pre from post. You can use either one, but just remember which one which direction you're going, so that you can use your direction-based hypothesis to determine the significance. We're not determining significance in this video. We're just going through the mathematics of how to calculate it using Excel. So I have my difference and I slide it on down. So that calculates my difference. I cannot just highlight and move those over. That's not what I'm trying to do. I want to know the difference squared. So I need to use equals the difference, or the column next to it, squared. Enter. There is my difference squared. So I don't have to find the squared value for every single one of my data points. I only need to know the squares of my difference values. So what really matters in this calculation is right here in my differences column. All right, now I need to find out my mean difference. So equals average, open parenthesis, select all my differences, and boom, I have my mean difference. This value is what's going to go right here in the top of my t equation. Okay. I also need to find my sums for my difference and my difference squared, because I have to find my sum of squares, I have to find my variance, and then I have to find my standard error of the difference, all pieces of my equation. So I need to find my sums. Equals SUM, open parenthesis, select my difference points, enter, enter, and now I have my sum of the differences and equals the sum of the differences squared. I need to actually change these because these are incorrect. I don't know why this is going that way. Equals average of these equals sum of these. Okay. I think it's because I barred those off. So I made sure that my calculations are correct. Always make sure that your cell calculations are correct, especially if the numbers don't look correct. Check back, make sure. So now I'll go through my sum of squares equation. Look, I'll create a equation for my variance and my standard error of the difference, and then my t statistic. How I calculate my sum of squares, we've done this before, but now we're looking just at the difference. So equals the sum of squares, or the sum of the differences squared. So that would be my data point here. So I'll open up a parentheses for that, minus, open up another parentheses, and now I need the sum of the differences quantity squared divided by n. I know that n right over here is 8. And then I can close out all those parentheses and have my sum of squares there. Now I need to calculate my variance. My variance is my sum of squares divided by my degrees of freedom. So my n minus 1. Because I'm calculating a dependent t-test, I don't have to look at the degrees of freedom of 2 groups because I only have one group of individuals, only one group of participants. I'm just measuring them twice. This adds to the strength of a dependent t-test because now there's not going to be variations between groups and between individuals. There's only variations between individuals and then pre and post interventions. So we lose degrees of freedom in an independent t-test because we have that added variance. With a dependent t-test, it's almost as if we gain degrees of freedom. So we have some more room to speak. So now I'll calculate my variance, so my sum of squares divided by my degrees of freedom gives me my variance. Now my standard error of the difference is the square root of the variance divided by n. So equals SQRT is our square root function. And then I'm going to put my variance divided by my n to get my standard error of the difference. And finally, my t statistic, okay, the top of my, or the numerator, the mean difference, minus my hypothesized difference. Based on my null hypothesis, I know that there is no, or I assume that there is no difference pre and post. Okay, so that will be 0 always as long as we have a null hypothesis. Okay, divided by my standard error of the difference, and I calculated my t statistic here. All right, I will post up these data points or similar data points so that you can go through your own practice calculations. This will be similar to our independent t-test where it will be a little extra credit opportunity. If you have any questions, please let me know. I'm happy to help. All right, I hope to see you soon.